Hello and welcome everyone. Welcome to the Pittsburgh.net user group. Thank you for everyone joining us today. We have an exciting topic, which is putting the SQL in NoSQL. And we are delighted to have you all today here to learn about that. During the next hour, we will be hearing from our invited expert speaker, Matthew Grooves, who will share his knowledge and experience. He's also a senior product marketing manager for Couchbase. We are very fortunate to have you here, Matt. The agenda will be as follows. Like, we are talking about SQL++, basics of SQL++, how do we use it, transition of using with the modern NoSQL technology. And we will follow that with Q&A sessions. If you have any other questions in between the session, like, please feel free to put it in the chat box and we'll be able to take that. Without further ado, I will invite Matt here. Hey, Matt, welcome.
Hello, thanks for having me.
All yours.
All right. Well, thank you for that nice introduction. I appreciate that. We're going to talk about putting the SQL back in NoSQL today, and we're going to be using SQL++ to do that. So my name is Matthew Groves. I'm with the marketing organization, Couchbase. My title these days is a DevRel engineer, but it doesn't matter what my job title is. My job is to help developers and show cool things to developers. So that's what I do. Today, we're going to talk a lot about SQL. Now, hopefully you're familiar with SQL. I think most developers are familiar with it, probably know how to write SQL. This is some SQL on the screen here. Even if you only have a passing familiarity with SQL, I think this is still relatively easy to read. Just give me everything in inventory where the price is in a certain range, and the item is either on sale or there's less than 20 of them left. And I think that's relatively straightforward here. That's one of the great things about SQL, is that it is designed to be as readable as it is easy to write. And if we're honest with ourselves, we spend more time reading code than we do writing it. So I think that's one of the reasons why SQL has been around and been successful for so long, since the late 70s. This is a screenshot from the documentation of a popular NoSQL document database. And this query is not SQL, returns the same results. But I would argue that it's harder to read this, harder to write this. And there's fewer people in the world who can read or write this type of language compared to SQL. Yet in the NoSQL world, I mean, what choice do I have, right? If I want the benefits of NoSQL, so I have to learn a new language that's, perhaps an inferior language. Well, I think we can do better than that. So we're going to talk today about going from relational data to JSON. I think that is an important difference between NoSQL and SQL, is the way that data is stored and modeled. And happy to answer any questions about that. I want to focus on SQL today, but if you have questions about NoSQL in general, happy to answer those anytime. Just throw them into the chat there, and I got them on my other monitor, so I can address those as they come in. And then I'm going to walk through some of the basics of SQL++, which I think is a really good answer, taking some of the best things from the relational world and applying them to the non-relational world, so we can have the best of both worlds. It's kind of the goal there. And then I'll spend a little time how to get started. And then I do have a small demo that I can kind of show SQL++ in action. But I'm happy to, again, address any questions at that time as well. So let's get going here. Relational data to JSON. And this is a relational model for customer. Pretty standard kind of, 5 tables. With foreign keys and so on. So the customer table has things like name, ID number, whatever else is in there. The billing table might include payment methods, billing addresses, and so on. Contact table might include addresses, email addresses, phones, whatever. I mean, that might even be 3 tables or more in some models. Purchases, which includes a history of items that a customer has bought. the date of their purchase, maybe the price history, and so on. And then connections might be a customer's relation to other customers. For example, a streaming service might have multiple users on the same account, but we want to keep those separate profiles because their preferences are stored differently, right? I'm thinking of Peacock, Netflix, things like that. Or maybe there's a social media aspect where you can friend and follow other customers, something like Amazon or social media where you can follow an author or whatever. So relational databases, relational data modeling is very, very popular. I'm not going to get into all the benefits of what makes relational great. Actually, I might get into some of them, not all of them, but I'll get some of them later on. But what are the drawbacks to this approach? Why do people look to other databases to solve problems? What are the challenges that relational data can have? So I really think of them as 4 high-level challenges for relational databases, and these are the reasons you might consider NoSQL. So the first one is, historically, this is the most important one, is scaling. When the number of users increase, so do the demands on the database. Now, these relational databases, especially legacy ones, they're designed to scale vertically, right? So I can upgrade to a bigger machine, but to handle more operations, but that can get very expensive. And then the other approach is called horizontal scaling, where I'm going to have multiple machines, I cluster them together in some way. But that, I'm not going to say it's impossible, but it is very, very challenging to do in relational databases. Sharding relational is difficult and complex. It can be done, but it is a challenge. The next thing is flexibility. I think this is what appeals to developers the most about NoSQL, because making schema changes to relational models can be painful, can cause downtime, can cause me to have to come in at 2 a.m. on a Saturday. I don't want to do that. Performance is another one people point to. Legacy relational databases, they kind of have their roots in the days of hundreds of users, not hundreds of thousands or millions of users like a modern website might need. The data being flat means that for complex entities, you got to model them with multiple tables, like in that earlier example. And that could mean a lot of joins. And if you need all that data, that could mean slower performance. So we'll talk about that for sure. Availability is the last one, this is more about distributed databases than it is about NoSQL in particular. It's just that NoSQL does distribute it a little better. But a typical legacy deployment of one server means that there's a single point of failure for your application. And again, you can configure replication servers, not impossible with relational, but the constraints on relational data mean that this could cause a performance hit. Other issues could come up there. It depends on your SLA, on how difficult that's going to be. So these are the reasons that a document database, a JSON docket databases are considered or possibly used in conjunction with relational databases, and in some cases replace them completely. So in a JSON document database, the data can be more centered on the root data, in this case, the customer. So we have, it's not a table anymore, it's a collection of JSON documents. And each one of those JSON documents can represent the entire customer. And so I can embed all the billing information, connections, purchases information into a single piece of data, a single document. Because I'm using JSON, so I have arrays and objects and arrays of objects and so on. And so each document now has its own, I'm going to call it a self-described schema. So if a developer wants to add a new field to their class in their code, that field is going to be saved to the document. I don't need to change schemas in the database itself. I can now even closely map these objects. I don't have to go through an ORM or any sort of mapping. I can just take JSON and serialize it and deserialize it back and forth to my objects in the application. So I think that's what really appeals to developers, is removing all the extra ceremony of relational databases. So let's just do a quick side by side. We've got a model on the left. This is kind of that 5-table model I showed you earlier. This is the traditional legacy relational model. At least 5 tables, probably more. I can't fit them all on one slide. Potentially lots of joins, lots of overhead as well, because if I want to update 2 pieces of this data and they're split up into 2 tables, I need an ACID transaction to do that, which is not a big deal. It's just more overhead. Lots of schema that I have to carefully manage and change. And A lot of times people will say that having a schema enforces your data to take on a certain form, and it's better for having consistent data. But I think we've all seen schemas gone wrong in relational, so it's just as easy to make a mess of your schema in relational, I think. Now, on the right-hand side, we've got a single JSON document in a document database. So I can retrieve that whole customer with one GET operation. Just look it up by its key there, CBL 2016. So I can store that whole complex graph of arrays and nested objects and so on in one document, and then serialize, deserialize that to and from objects in code directly. No need for ORM there. So this is kind of a side-by-side, what I want on the left and how I could model it in JSON on the right. And I have a whole separate session about document modeling. If you have questions, I'm happy to answer those, but we're not going to focus much on modeling today. But at what cost? What are the trade-offs here of using JSON? Because there's nothing that doesn't have trade-offs in software, unfortunately. There are good things about relational databases. Like I said, there's a reason that SQL has been around for a long time. There's a reason that relational has been around and continues to be used. And those things I think that are good about relational is SQL. So SQL isn't necessarily required to be a relational database, but for the most part, they go hand in hand these days. We kind of associate them as the same thing. If you say SQL, you probably mean relational. It's an incredibly popular language. It's concise, declarative, lots of training materials, designed to be read by humans, and it's a great language. So that's a great thing about relational. That's a lot of those SQL databases just kind of throw away. Joins is important as well. So in that last model, I showed everything crammed into one document, but I can't always do that, right? Sometimes I need to model a many-to-many or a one-to-many as separate pieces of data. And lots of reasons why you want to do that. And so if I can't join my documents together, now I have to do a series of multiple lookups or figure out some other way to get that data. So the joins as part of SQL and part of relational, they are still very useful and still very good things to have. And ACID transaction is also just kind of the other side of the coin of that, because not every use case can fit into one document either. Even if I embed a bunch of arrays and data, I can't necessarily embed everything into one document. So if I need to transfer money between accounts, I still need an ACID transaction to pull off something like that. And multiple documents can be critical. So having ACID transactions, again, this is something that has been associated with relational for a long time, and is something that is definitely a good thing when working with data. So enter SQL++, and I think this is taking those really good things about relational, about SQL, and really good things about JSON document databases, and combining them into one technology. So it's SQL++, just to give you the textbook definition, it's a semi-structured query language that encompasses both the SQL and the JSON data model, and is SQL backwards compatible. And a little history, this was something that was it came out of a project at UC San Diego as a research project they called SQL++. Couchbase was actually the first database to add SQL++, commercial implementation of it, SQL for JSON data. And there are a few other document databases out there that you may have heard of that have at least a partial implementation of SQL for JSON. So a couple worth mentioning is Particle. You may not have heard of Particle, but you've probably heard of DynamoDB. Particle is I'm going to call it an experimental language for use with DynamoDB to provide some SQL to that. Cosmos DB, this audience being a .NET group is probably most familiar with this one. It has this is an Azure only database, and it has a little bit of SQL in there as well. Now both those implementations are, I wouldn't call them a full SQL implementation, SQL++ implementation. They lack things like joins and other features. So it's a step in the right direction though. And also thought I'd mention Apache Ignite. It's not a JSON database per se, but it does have a SQL implementation, and it's not a relational database either. So it is a semi-structured data. I thought I'd mention that as well because it has a very good SQL implementation but a more relaxed, non-relational data. I also would like to point you to this book over here, which is actually, I think, due for a second edition, if you ask me. But this is a book written by Don Chamberlain. And if you know your history, you know that Don Chamberlain is one of the inventors of SQL, along with, I think, Boyce. I think Edmund Boyce? Boyce was the other one. So Boyce and Chamberlain, inventors of SQL. And Don Chamberlain actually is a technical consultant for Couchbase and helped to write this book, SQL++ for SQL users. So I guess only like total SQL nerds care about that sort of history, but I think it's very cool that we've got Don Chamberlain on board. And this book is available for free if you want to check it out online. There's print copies you can buy as well, but you can get for free as a PDF there at that couchbase.com link at the bottom. So I'm not going to go through that whole book today, but we're going to go through some of it, scratch the surface of what's in there. So kind of how does it work? I'm going to take you through the basics of SQL++. I'm going to touch on those three things, the SQL joins and ACID transactions, and how they might work in SQL++. So let's start with a little bit of a translation guide here. This might be a good place to hit print screen and take a little screenshot for reference later. But this is a list of terms you'll see in the relational world if you're using relational databases. I'm assuming this audience here is probably most familiar with SQL Server, so that's the one I chose. That's the one I'm most familiar with as well. But they're going to be similar if you're comparing to Oracle or Postgres, etc. And this is kind of how they translate to the NoSQL world. And again, I've chosen a Couchbase here because that's who I work for, but you're going to see very similar terms in other NoSQL databases. And this is a simplification, right? There's a lot more details to it than this, but this is a pretty good baseline for getting started and understanding, the different terms and what they mean. So let's just go through a couple of them here. So I mentioned at the first level, server and cluster, I mentioned that NoSQL databases are typically distributed, so they're meant to have multiple machines running in a cluster, whereas a SQL Server is generally meant to be run on a server. And you may configure other you may have other configurations, but generally speaking, that's the way it works. And so by being a cluster, you get improved scalability, high availability. And the other thing that Couchbase adds to the equation is built-in caching. We're not going to touch on that very much, but it's there as well. Down at under the server, you'll have like a catalog or a database, depending on what you call it. You can have multiple catalogs, multiple databases in a server. Couchbase, you have multiple buckets in a server. That can be a confusing term. It's not related to a AWS bucket, if anyone here is familiar with AWS. Under a catalog, you might have a schema in a relational database. In Couchbase, you have a scope. Oftentimes, we don't use those. We just use DBO, or in Couchbase, we use default, but it is there. You need it for things like multi-tenancy, for instance. A table level in SQL Server, obviously the most important part of databases are the tables, and similar level in NoSQL database is collection. Couchbase calls it a collection. Mongo calls it a collection. I think Cosmos does as well. And so on. I'm not going to go through all of these, but you can kind of see the translation. They're very similar levels of organization, very similar concepts, but they're not the same. It's not just renaming these concepts. It's just, this is kind of a guide to help get you oriented in the NoSQL world before we dive into actually writing some queries. So I see a question there in the chat, and I'm going to come back to that at the end if that's okay, because that kind of skews into data modeling, and we're not going to get into that too much today. All right, so let's get into some SQL++. How does it work? I'm going to assume you have some familiarity with SQL already. If you don't, that's okay, as long as you understand that SQL is very popular, right? Used by pretty much everybody. What I hope to show you is that SQL++ is not very different from SQL at all, but allows the developer to get up to speed very quickly with the familiar language, and in the meantime, get the flexibility of JSON data. So let's start with some sample JSON data. This is from a sample database, and this contains travel information. This particular document exists in a collection. The collection is called route, so it's a bunch of routes. And so it's kind of like a table, if you go back to that last chart back there. It does not have enforced schema or constraints, right? Now, each document has a key. Now, this is kind of stored in different ways from database to database. So Couchbase stores it as metadata. It's not actually in the JSON itself. Mongo and Couchbase have like an underscore ID, like a sort of a magic string for the key, but it's the same kind of concept. So in the JSON, notice that this route has a source and destination. So this is an airline going from one airport to another. And also notice it has an airline ID field, which we can kind of, I got foreign key there, but it's in quotes because again, this isn't relational. So there's no constraint here on the actual JSON that's enforced by the database. But it works similar to a foreign key where I can actually look up airline 24 and get the airline that's associated with this route. And the last thing, which is kind of makes it stand out from relational a little bit, is that schedule field down there, which is an array. So in relational, this would typically be 3 rows in another table, and there'd be a foreign key involved. But in this case, it's I'm going to call it denormalized into a single document. So relational world, I'd have 2 tables and at least 4 rows to represent this. In this case, I just have the 1 document. Okay, let's see. Jacob, question about putting JSON to SQL database. Yes, okay. Yes, that is a question I get a lot about why not just use the JSON capabilities of a relational database? Well, so I think depends on which database you're using, right? So SQL Server, for instance, is actually still kind of new to the JSON game. So you can do some things. I don't think it supports indexes just yet, for instance. So that's going to make performance challenging. Postgres is a little better, I believe. I think they might have some limited indexing there. So kind of my guideline to using JSON in relational world is if you need a little bit of flexibility in your use case, but you don't need, all your data to be flexible, or most of your data to be flexible. If you just need one little piece in a table, you might be able to get away with that and not tank your performance, for instance. But I would be very careful about using JSON extensively in your relational database. Make sure you understand the performance implications of that, because yes, you get the flexibility, which is nice. Sometimes you got to go through a few extra hoops to parse that JSON. Right. In this case, it's a little more native, right? We're dealing with JSON directly and exclusively. But in the relational world, you have to sometimes toggle back and forth between them. So that can be a little tricky. Okay. So that's the route. The next thing I want to point to is the airline. So this is the airline 24, which had it was the airline ID in this document. But airline 24 is a separate document with its own key. It's in its own collection as well, called airline. Now, in this case, the data is very flat. So this is not much different than a relational table. It's just kind of one row, but it's storing it as JSON. This one does contain the name of the airline, though. So you can see there at the bottom, the last one says American Airlines. So this is where the name of the airline actually exists. Okay, so we've got that data in place and a bunch of other documents that look like this, right? So we've got a bunch of routes and a bunch of airlines, for instance. So let's look at what a SQL query, SQL++ query would look like on this data. So if you used SQL before, I'd say this is pretty much exactly how it would look. No difference at all. We're selecting from a collection instead of a table, right? But the syntax here is identical. And it is backwards compatible after all. And the result of this query would be JSON data, not rows and columns, but an array of JSON objects. So you can see here I'm selecting airline ID, destination, and source from all my route documents. I actually limit the first 10 of those route documents. And it'll output those as a JSON array. So there we go. So if you already know how to write SQL, then guess what? You are already about 75% of the way there to writing SQL++. Go ahead and put it on your resume. All right, let's make it a little more. Oops, we're in the wrong direction here. Oh, no, I'm not. Okay. Okay, so now the question is, well, how do I get that airline name? Right, so this has the airline ID, but I can't really show airline ID to my end user. They don't know what airline 137 means. So how do I get the airline name? And this becomes a modeling decision. And this maybe touches on your question a little bit from earlier there, Ronald, is about duplicating data. So one thing I could do in a NoSQL database is I can go back to these routes and I could look up the airline name and I could store it here in the route. So I have the airline name now in two places. It's in my route and it's in the actual airline document. So this is a denormalization. This is a duplication of data. Now this will be frowned on in relational database because you're not supposed to duplicate data. You got to keep it in third normal form, right? But this does eliminate the need for a join. I don't have to now go get the airline document or airline row. I can just get it right here. It takes up more space, but storage is very much cheaper these days than it was in, say, the late 70s when relational kind of first came into prominence. And the important thing to consider here is how often does that airline name change, right? If the airline names hardly ever change, and do they change very often in reality? I mean, maybe there's a merger every, 5 to 10 years, something like that. That might cause us to have to change this. If we can accept, we have to update this only every 5 years or so, or even every year even. That's pretty acceptable for a performance benefit there to cache this this data, to duplicate this data. Now, if however we want to join to something that maybe changes a lot more often than airline name, say a person's I don't know, the person's address, or I don't know, a person's preferences, or whatever changes a lot more often or changes unpredictably. Well, then it may not make sense to denormalize or duplicate that data because we're going to cause ourselves some headaches there. We have to check in multiple places and update this in multiple places whenever that data changes. And we run the risk of the data being out of sync or outdated, right? Just like a cache. So in that case, you may want to keep the data separate. You don't necessarily always have to normalize, but normalization is still an option. I said I wasn't going to get into modeling too much, but I guess I am getting into modeling. So with SQL++, you can use a join. So yes, we have joins in the NoSQL database. If that was something you thought, oh, well, NoSQL sounds good, but I can't do a join, so what good is it? Well, NoSQL has joins now. So we can do inner join, left join, right join, just like relational database. And this is what it would look like. So I'm joining airline to the route, airline collection to the route collection. And you might be wondering about that meta function in there. That's a little weird looking, right? You don't see that in relational too much. Well, remember I mentioned earlier that the Couchbase stores its key in the metadata, not in the JSON itself. So if I want to use that in a SQL++ query, I just have to use the meta keyword to grab that ID. Easy as that. So the results will look like this. Join the data together. So this time I'm getting airline ID, destination source, and I'm getting the name from the airline document. And so we can see the airline 137 is Air France. And now we can show that to the customer because Air France means something airline 137 doesn't. Now, a join is still overhead, just like relational. So this is going to be slower and require more processing and latency than if we had cached the airline name in the document and duplicated that. But that might be acceptable in some situations. Right? With modeling and embedding, oftentimes we can reduce the number of joins that a query needs to get better performance. We can always work towards reducing our models to embed as much as we can, but not everything, right? So that's why the join is here. I did mention Cosmos and Dynamo earlier. They do not support a join like this, in fact. So that's one thing that they're kind of lagging behind in SQL++ area is you can't do this type of join with those databases. So this is an example I took from Couchbase. All right, let's get a little more complex here. And I want to show this query here, not because I'm going to go into every single piece of syntax in SQL++, but I think this really shows the power of SQL, expressiveness, concise nature of SQL. So I want to know which airlines are the biggest airlines, which ones have the most routes. So in this case, I'm going to use an aggregate function, count, with a group by name. And then I'm going to qualify the aggregate with a halving. Only show me the ones that are 2,000 or more routes. If they're smaller than that, then I don't really care about them. If it's just, Joe's plane service from Columbus to Dayton or Columbus to Pittsburgh, it's just one plane. I don't need to see that on my list. Just show me all the big ones. And I'm going to order them, biggest to smallest in descending order. And now this is 8 lines of code here. And I could probably condense it down to 6 if I wanted to, combine that select statement and that join statement. But it's more readable if I have it in 8. And this is, with SQL++, I can run this type of concise and readable query on JSON data. And this is the results I'd get. American, I don't know if this data is probably pretty old. I don't know if these are still correct, but American has 2,354 routes and United second place, etc. So select, join, having, order, all that stuff there is in SQL++. So it's a full SQL++ implementation. It's, a lot of NoSQL databases, you'll see they have a SQL-like syntax or something that's similar to SQL, but it's not SQL. And SQL++ is the next iteration of SQL. The plus is just, we need some extra stuff to deal with JSON. Okay. All right, so let's, I'm not going to go through all the syntax. Like I said, that's all in the documentation, right? We don't have to go through that. You can all read that documentation if you want to, or read that book if you like. But let's touch on a couple other points, some good things about relational that have made their way into SQL++ and therefore into NoSQL. So ACID transactions, this is kind of the standard ACID demonstration. Right? I have 2 different accounts here. My account and my balance, and then my daughter's account and her balance. And of course, we know where this is going. If I want to transfer an amount, that means a debit from Matthew and a credit to Emma. And both of those have to happen, or neither have to happen. We can't do a halfway because that's going to be creating or destroying money. And that's not going to make our customers very happy. So we have to have 2 documents and we have to have 2 operations, and those both have to happen. And so how we normally deal with that is an ACID transaction. And ACID transactions have syntax in SQL that look like this, right? Begin, and then a series of SQL statements, and then a commit to wrap all those in a transaction. So we can see the first one is adding a balance to Emma's account, subtracting a balance from my account, and then we're going to just select them both just to verify at the end, and then commit transaction. And so it's easy as that. So now we've got transactions with SQL on JSON data. And there's also a rollback. I'm not showing all that kind of stuff. There's also things like save point, so more advanced transactions, more complex scenarios. Now, one thing to keep in mind, different from your standard, SQL Server relational database, is that this is distributed. So customer 1924 and customer 4872, they aren't necessarily on the same machine in the cluster. So this involves some networking. So there's overhead, right? So just like in relational world, there's overhead to an ACID transaction. So again, if we can model our way out of having to use ACID, then let's do that. In this case, of course, we can't because we have 2 separate accounts. It wouldn't make sense to embed one account in another. If it was my daughter, maybe it would be, but eventually I'm transferring money outside of my family. So it makes sense to have this be an ACID transaction, 2 separate documents. So ACID is there when you need it in SQL++. Indexing is important. And in the chat there, raise your hand if you love indexing, if you love dealing with indexes. And if it's a group of developers, I'm going to see no hands raised. But that's a great skill to have, by the way. If you do like indexing, then that's a really important part of SQL. The syntax is very similar to create, index in the relational world. Of course, the difference here is that these things refer to NoSQL building blocks, right? Bucket, scope, collection from that earlier chart, instead of catalog, schema, table. Now, this first index here is called the primary index. Now, this is something that Couchbase has to enable SQL queries to scan all documents in the route collection, every single document. So this would be kind of like a full table scan. So this is something that's good for development or maybe some edge cases, but generally speaking, this is not something you want to do in production. You don't want to have a full table scan, or in this case, a full collection scan. You want to have more specific indexes than that. The second index here is more indicative of an index for production. It's an index on the same route collection, but it's only indexing the source airport field. So therefore, any query that is filtering on source airport, like some sort of predicate, could use this index and get a faster result than scanning every single document. I'm going to show you some examples of execution plans when we get to the demo. Now, as in relational world, indexing is a very deep topic and something of an art form to get right. And I've never been very good at it. Fortunately, in SQL++ and Couchbase here, there's an index advisor that can make recommendations for indexes based on the query. So maybe a little hard to read here on the screen. If you could just zoom in maybe a little bit, if you can. I'm not sure what's available to you out there in the viewing world, but this is the query here. This is going to query airline routes, and it's going to query based on airline ID or uppercase of an airport, equipment number, and so on. Now, with this query, I can click on this advise button here. And this advise button is going to spit out some recommended indexes that will help speed up the query. So if you've used SQL Server before and create indexes, you've seen something like this as well. It's going to help you build indexes. Now, you shouldn't necessarily just blindly add every index it suggests, right? And it's not always going to give you the most perfect index because, again, there's a bit of an art form to indexing. But this gives you a great place to start. And I'm going to show a little more on that when we get to the demo. The other thing to think about is cost-based optimization. So if you're deep into SQL Server, you're probably familiar with this concept. But if you have a bunch of indexes, if you're following a rule-based optimizer as opposed to cost-based, you're going to go based on the order of the predicates, right? So if I had a query like this one, where the order is name, zip, status, then I'm going to look at these indexes and say, okay, name, zip, status, I'm going to use index 1. If I went in a different order in my query, I'd say where zip, status, name, then I would be using index 3, zip, status, name. I'm going in a order based on the order of the indexes. But that kind of raises a question, which index should I be using? What order should I write my SQL query in? And that's a world of pain when you get into there. So a better approach, I think, is to actually take the cardinality into account. If we understand what cardinality is, if not, no big deal. Just think of it if I have data and I have, let's say there's only 5 different zip codes in the whole system. That's going to be a relatively, that's going to be different cardinality than if there are 5 million zip codes in the whole system. Okay. And now with JSON data, it gets even crazier because it's possible that the zip is a string in some documents, a number in other documents, and it's possible that it's missing in another document. Now, hopefully you're not doing that. You don't want to build your data that way, but it is a technical possibility. So a cost-based optimizer has to take that into account. So what that's going to do is it's going to pick the best index based on statistics. And what do we need for that? We need to update statistics. So just like you would in the SQL world, update statistics for a table, you can do the same thing for a collection. All right. Let's just run through a few more things. I get asked about store procedures a lot. What about Sprox? Can I put Sprox in my NoSQL database? And some of them, yes. So I think Cosmos DB has Sprox, for instance. I think you have to write them in JavaScript, if I'm not mistaken. So Couchbase does not have Sprox, at least not yet. It does have something called user-defined functions, which oftentimes can do some of the same things that Sprox can do. And I think Cosmos also has user-defined functions. And you can, in this case, in Couchbase's case, you can actually create a user-defined function using SQL++. So you can use the same language that you are using for your queries inside your UDF. And this is a function that will list airlines by rank for a given country. And this is about as close to a Sprox as you'd find in Couchbase. Maybe more coming in the future. And I said I think Cosmos DB has them now, but they are, I think, JavaScript only. So you can go that way. Another feature I get asked about a lot is, what about triggers? Are there triggers in NoSQL? And triggers can often trigger an argument when developers start talking about them. Because, well, some people like never use triggers, or some people like always use triggers. Some people use them sparingly, and I think that makes the most sense. But in the NoSQL world, in Couchbase anyway, there's this idea of eventing, which is similar in that it allows you to write code that responds to data changes. Now, I bring this up not because I want to go through every feature of Couchbase, but because inside this eventing function, it's JavaScript code, but notice that right in the middle there's a little SQL just right there embedded in the JavaScript, and Couchbase is able to parse that embedded SQL and even put in the arguments like the min distance there. I think that's pretty cool. So it's not quite a trigger. It doesn't block anything. It can't check constraints or anything like that. It's asynchronous, but it's similar, and it'll execute on the database itself. So if you want to write some logic or code that runs on the database, kind of share it between applications or whatever, this is one way you could do it. All right. Last SQL related feature I want to talk about is analytics. Couchbase offers an analytics service, and if you're keeping up with your Forrester and your Gartner and so on, you may have seen this referred to as HOPE or HTAP, depending on which analyst you are subscribed to. But the idea here is that it's a hybrid of operational or transactional and analytical processing. So what this means is that if I have a database and that database is used for my website, if I want to run some reports on that data, they're complex reports, complex SQL, I run the risk of locking up that database or really taxing that database and then affecting the day-to-day users, increasing their latency, that sort of thing, possibly even crashing the database, God forbid. So the idea is that historically you would have a copy of that data copied off to a data warehouse or something every 24 hours, for instance. And so you get a copy of that data, and that's where you run your complicated queries to do your reports, your dashboards, and whatnot. Of course, the issue there is that now my dashboard, my reports could be up to 24 hours old. If I want more real-time data, I use something like Couchbase Analytics or the HOPE or HTAP type offering, where it's going to make a copy of that data, but it's going to do it in real time. So once a piece of data is added to the data service, it'll automatically get copied into the analytics service. If it gets deleted, it'll get deleted from the analytics service, and so on. But beyond that, that's where the interaction ends. If I run any queries on the analytics service, the workload there is isolated. So that way I can run my complex ad hoc stuff, my machine learning, my data science tools, my graph, my visualizations, and so on, without affecting the actual workload. So that's about all I'm going to say about it, except that the queries are running, can use SQL++ as well for analytics service. And I can also, if I want to, bring in external data sources. So for instance, our AWS S3, Azure Blob, Azure Data Lake, Parquet, and so on. I can bring those in with my data to do reports amongst multiple sources of data. So I think that's a pretty cool feature, but it can all be done with SQL++. And before we get into the last part, people ask about moving data from relational into Couchbase, like what's the best way to do that? And the usual tools for moving data around still apply. Just build an ETL, set up a Kafka pipeline, and so on. But I want to point out two specialized tools that are good for NoSQL if you want to move from a relational database into a NoSQL database. These work with Couchbase and others like Mongo, etc. But they have some capabilities that can really help you with your modeling. So DataWorks can create data pipelines, real-time data pipelines, but it can also perform modeling changes on the fly. So think back to that slide where we had the 5 tables and we combined it into the one document. DataWorks can actually do that for you as it's moving data over. It can do the remodeling for you. GlueSync is a similar offering from another company. It can do real-time replication from relational to SQL++, and that's been especially useful for companies who want to take advantage of some of Couchbase's great mobile sync capabilities, but don't necessarily want to drop their relational database just, or can't drop their relational database just yet. Okay, seeing the question, what does meta mean in SQL++? So in the case of Couchbase, I think I covered this. Meta right here. So in Couchbase, let me just go back a little farther. Right here, this is a route document in Couchbase, and it has a key of route_5966. That's right up here at the top. That key in Couchbase is not inside the JSON. It's actually metadata about the JSON. In other databases, you might see inside the JSON, you might see _ID, for instance, might be down in here. So because it's metadata, we have to then pull it out a different way with the meta function. There's other pieces of metadata as well, but ID is the most common one when we're writing SQL++ queries and doing these types of joins. Okay, hope that answers the question. Let's go back to where we were, DataWorks and GlueSync. Okay, so those are two tools that I would look into if you're interested in synchronizing, moving, migrating, keeping relational or not. These tools can both be helpful to bring some of the benefits of NoSQL. All right, so how do we get started? Well, I think obviously it's no surprise that I'm going to recommend Couchbase to you. Start with the Couchbase Capella. This is Couchbase's cloud database as a service. 30-day of free trial going on right now. No credit card needed for that. You can get up and running in minutes. And the travel data I've been showing throughout this presentation is built into Couchbase Capella as well. So you can run those same queries that I've showed you and run them there and start tweaking them. And if you want to go further and start, coding in some .NET, for instance, some C#, there's an SDKs available. You can connect to Couchbase Capella and start building an app. If that's too much work for you to sign up for an account, that's totally free. No credit card needed. You can also check out the Couchbase Playground, which is totally browser-based way for you to start coding immediately against Couchbase. Don't need to leave your browser. You can just, there's code samples right in the browser. You can tweak them if you want to, play around with them. It's an actual true playground. .NET's there, but any other languages you want to try as well. Also, SQL++ is one of the options. You can just try SQL queries directly. And if you want to, you can actually connect this to your Capella trial if you want to do a longer running type of demo. And speaking of demo, I think it's time for a demo. So I'm going to bring up a browser here and sign in here and see if there's any questions while I'm doing that. Okay. Do I have my cheat sheet somewhere? Yes. So I have a cheat sheet off the screen here, so you don't have to watch me type and make typos, but I've got some sample SQL++ statements to kind of walk you through some of the things that I showed you. So this is Couchbase Capella. This is not the trial. This is the full paid versions, but not everything I'm going to show you can do in the trial version as well. But I have my cluster here. I'm going to go to Data Tools, and I get this Query Workbench. This is where I type in my SQL right here. This is where the results are. So let's just do something real simple here. Where's my zooming? Okay, there we go. So there is a select star from landmark where content like, and I can use a string with some wildcards and limit that to 10. Go ahead and execute that. And so there's the result. I'm getting 10 documents as my result. Took 61 milliseconds, and there's the size of the results and everything. So there's the JSON documents there. You can see in just raw JSON format. I can also put those into like a table view. It's still JSON behind the scenes, but I can sometimes it makes sense to put them in a table view like this just to see it in the row format, but it's still JSON data. One thing I do want to point out, I'm not going to talk much about this today unless there's questions, but if you're doing this type of text-based search, doing anything more complicated than this, I'd recommend not using just SQL to do that. There's actually in Couchbase, there's a built-in full text search that allows you to do Lucene-like searches on that same JSON data. So that's where I'd recommend creating a search index and executing that instead. Now you can actually execute full text search. I'm not going to do this, but you can actually do a full text search from here in SQL as well. See, this is why I have the cheat sheet to copy and paste from, because I can't type. But that has its own syntax and it's a separate function. So I'd recommend doing that instead of using wildcards and trying to build your own search engine. Okay. Another one I get asked about on Stack Overflow a lot is, what about SQL queries and arrays? So if you remember that schedule array in a Couchbase, there's actually some new syntax. This is the ++ part of SQL++. So I've got any in satisfies. This is kind of like a little bit of lambda function, but for any s in schedule, so any element in the array, this predicate will match anything that satisfies this condition here. So the flight equals AF547. Let's go and execute that. Hopefully you'll see what I mean. So here is the first route, the schedule array, and one of those flights in there, AF5 matches AF547. So therefore it returns this route. Now you might have noticed that query took a little bit of time to run. It took 1,626 milliseconds, which is an eternity. We can do something better than that, right? So why don't we look at the advice and see if it suggests an index? And actually, we should probably do something before we do an advice. Let's do this again. Let's execute this query. Let's bring up the plan. So if you're in SQL Server or Postgres, you've probably seen something like this before, where it shows you graphically the different steps of the query and what's taking this so long. And right away, the red flag to me is it's using the primary key here. It's a primary scan, which is bad for performance. It's fine for developing queries and getting started, but it's bad for production, bad for performance. So this is probably the reason that this is so slow. It's actually going through a full fetch here. You can see it's fetching all 23,000 documents and then filtering down to 11. And then we're going to project, because we're only limiting it to 10. So we're just taking the first 10 of those 11. So it has to query all 23,000 documents, and that's why it's so slow. So if we can go ahead and hit the advise, it will suggest a better index. So here's one right here. This is the current index it's using. So you can see create primary index. This is the one it suggests that I use instead. And this one's going to do all kinds of funky syntax here. Distinct array, flight for S and schedule. This is the kind of thing I mean when I talk about indexes being an art form, that I probably would have a hard time coming up with this myself, doing this manually. And we're in the age of ChatGPT. We don't need to do things for ourselves anymore. Have the computer do it. So this is kind of like ChatGPT for indexes. It's going to help us create an index for better performance of that query. Okay, what's next? I've got, okay, I also get asked a lot about paging. What about, I want just 10 results or 50 results at a time. How do I do that in SQL++? And the answer is offset and limit, which are two great pieces of syntax from the Oracle and MySQL world that I don't think they're in SQL Server. I really wish they were. It's so much easier to do this type of paging than it is the SQL way of doing top and over. But anyway, SQL++, offset limit. So offset means skip the first 10. Limit means give me the 10 after that. Easy enough to do paging there. And we can also look at an execution plan for this. Oh, not for that. Execution plan for that. See, it's also using the primary key. It's not as bad this time because there's only 917 hotels. But if that hotel collection grows, then we're going to need to do something about this index, because this is going to be too slow. Another thing I get asked about sometimes, people, when I show people SQL++, they're like, oh, what about this? What about this? Can I do this? Can I do this? And the answer is almost always yes, I can do that. So here is an example of an embedded SQL++ query. So I wanted to find, oh, what happened? I pushed the wrong button here. Refresh. Okay, so I wanted to find out, yeah, I pushed the wrong button. I wanted to find out what are all the cities that have a landmark and an airport. So I have two collections. They both have city. I can't really join them I mean, I probably could join them on city, but I'm not going to join them on city here. I'm going to just do a subquery get all the cities from the airport and use that as a predicate with the cities and landmarks. So execute that. There we go. I've got 2,776 results of the city. So I can see from this query that Abbeville has both an airport and at least one landmark in the system. And so does Avignon and so on. There's some duplication here. So I also get asked about, what about distinct? Yep, distinct is there too. Now I have 84 cities in my database that have both a landmark and an airport. So these are the places that you might consider booking your next flight to do a little tourism because they have some interesting landmark there. One thing I want to click on here just before I finish this is I'm going to execute this and click on advise. Because interesting thing about this query is that, well, there's two queries in there, right? So I've got the outer query and the inner query. Right here, the advisor says this is an optimal covering index. What do I mean by covering index? So that means that the index it's using is right here. It's indexing the landmark collection. It's indexing the city field. So that city data is already in the index, which means if I'm querying just the city up here, and I am, I'm not doing l.star. You're not supposed to do star, right? We're not doing select star anymore. Is that right, everybody? But if I'm just selecting city, I don't have to go and fetch the data. I can just get the data right from the index. So a covering index is going to be way, way faster as long as I only need, 1 or 2 or 3 pieces of data from the index. So, okay, well, that's enough index nerdery for now. That's the demo I have to show you. So what kind of questions you got? We can go back and revisit modeling if you want to, but hopefully I kind of answered your question a little bit there, Ronald. But yeah, so the question was, if you want to track purchases, should you duplicate the data and create a purchases document? So I'm kind of curious about what you're thinking in terms of duplicating a document, a purchases document. So one of the things, I think this is an issue in relational as well, is that if you have an e-commerce system and you're selling things, sometimes the prices of those things change, right? And so sometimes if I go into Amazon and I made a purchase 2 years ago, let's say, I want to check on that item, see how much I paid for it, and I click on the link to it. Maybe I pay $20 for it, but today's price is $25. If I didn't duplicate that data, then my historical record would say I paid $25 for it, even though I actually paid $20 for it. So sometimes duplicating data, creating a snapshot of a point in time, what the state was when the purchase made, that just makes sense to happen, and that's regardless of relational or NoSQL. It just happens to be a little easier to do in NoSQL, because if the schema changes in the future, that's fine. Your historical schema doesn't have to change. So that is, hopefully that helps you answer your question about modeling there. Happy to come back maybe in the future and give you my modeling presentation on JSON data modeling. But that's also out there on YouTube if you want to look it up. Do a full presentation on JSON data modeling for document databases. Stephen, hey Stephen, good to see you virtually, I guess. Just soaking it in. Well, if you have questions, of course, you're welcome to contact me. I'm on Twitter these days. If anyone still uses Twitter, I'm on M Groves on Twitter. You can also find me on LinkedIn, Matthew Groves. I think it's just M Groves on LinkedIn. Matthew Groves. Happy to answer any questions you have. If you are done soaking it in and an hour later you're like, oh, I wish I would have asked that, that's totally fine. Go ahead and hit me up on Twitter or email is fine too. I think you have your group leader has my email address, so he can give it to you. Well, I just want to say before we close up that I appreciate you all being here for this presentation. I mean, this is after hours. This is work after hours, and there's lots of things you could be doing with your time. You could be at your son's baseball game, or you could be just relaxing with a cocktail. Maybe you are relaxing with a cocktail because this is virtual. But you've chosen to be at this group and listen to me for an hour, so I very much appreciate that, and thank you very much for joining us tonight.
Thank you very much, man. It's a real pleasure hosting you. Thanks, everyone, for joining us. I'll see you in the next one. Thanks, all.
Bye-bye.